What's going on YouTube? In today's video, I'll be showing you how to connect multiple Raspberry Pi Pico Ws across the same network to start sending messages and information between them using Thonny and MicroPython to get that started. So by the end of this video, you will be able to send messages between two Raspberry Pi Pico Ws to enhance your projects. And this can be particularly useful when you are working on much larger scope projects in IoT or home automation where you want to send information across different systems and you want to distribute processing across different devices. That is in this case, multiple Raspberry Pi Pico W. So this can have many different use cases and it is very easy to set up, and I will show you in this video how to do that, and by the end of it you will be able to do this very seamlessly. So the first thing you have to have in this video is some prerequisites. You have to have two Raspberry Pi Pico Ws at least, which we're only using two in today's video, but you can actually scale this to multiple devices. And you have to have them connected to your computer. I'm using a Mac today. And you also have to have the Thonny ID, which you can download online, and you have to have a valid internet connection. And that's pretty much it in terms of what you need in terms of hardware. And right now I have them connected to my computer. I have Thonny. And also what you need is, I forgot to say, is you have to have MicroPython on these devices. So it's really easy to get MicroPython on these devices. So you have to have that as well. So I have two devices. They're both connected right now. Right now we're looking at Thonny for one device. So if you have been working with Thonny for a long time, you probably have been only using one device. And to get started with using two devices in Thonny, let's ignore this code for now. We'll get back to this code in a second. You simply want to open Thonny and go to Tools, and you want to go to Options. And the first thing you want to do is uncheck this box. I already unchecked it, but if you have been using Thonny and you never played with this option before, you should see an X there. Just uncheck that X and click OK and restart Thonny. Okay, so now that you restarted Thonny, you should have the capability to open multiple instances. Right now, I currently only have one instance, and that's connected to my first device, which is the 11101. And you can select whichever device you want for this. To open another instance, I'm using a Mac. I believe if you're on a Windows or a Linux, you can just double click the application logo to open another one. I saw some guy do that online. But for a Mac, it's a little different and it's slightly buggy. What you have to do instead is you want to go to the terminal and you want to run this command. Now, I would imagine there's probably something that's similar in a Linux or a Windows machine, but I'm going to run this command and that's going to open the other instance. So let me go ahead and just run this, and it should open fairly quickly. So now it instantly opened the other instance and actually connected to my other device right away. But if that didn't do that for you, you can just select the other device. So now we have one device in one instance and one device in the other instance. And the little project we have today is one of the devices is going to be a server, and the other device is going to be a client. So we're just going to send messages between the two to prove that they work. So let's just go back to the server, the first one here. And so what we're doing is we're just bringing in some imports. This import I have here is a constants file that has my internet name and password and other sensitive information, so you can ignore that. And what I'm doing here is I'm simply connecting to the internet with this piece of code. So if you have the correct internet name and password, it should work there. And we're initializing a server socket with this block of code here. Once again, this is just a high-level overview of what I'm doing. And then we're just going to print listening on the address. And then the next thing we're going to do is we're just going to wait for a client to connect to our server. And once we receive the client connection, we're going to print the request. In this case, we don't have to really unpack it because we don't really care what's in the nature of this request. And we're just going to send a random number back to the client. Now, I would imagine for your applications, you probably want to send some sophisticated and useful information, unlike this. But this is just for demonstration purposes. So I'm just going to send that back. And I'm just going to print sent, and I'm going to close every time that happens. So we don't want to leave that connection open. So that's it for the server. And one thing you have to do is you want to change the IP address of the client to point to the proper IP address because it's going to be different for your application. So what I mean by that is if we go to the client code, which is on the other device, we are importing the same thing. We are connecting to the internet. But one different thing we're doing here is we're specifying a IP address to connect to. And this actually simply comes from this code, and that's if you uncomment this, you will be able to get that corresponding IP address. So that will be different. So you want to uncomment that, run it once, and just copy and paste that value into this value right here, and that should work fine. Okay, so let me go run the server code first before I get into the client code a little bit. So let's go ahead and run that. So we're listening on that, and it is port 80, so that should be the same for you as well. So we are listening, nothing's happening because we haven't run the client code on the other Raspberry Pi Pico W. So as I mentioned, same nature of imports, connecting to the internet. We point to the web server on port 80, and the main thing here you want to focus on is that we open a socket, we connect to that socket, and we're simply sending a message. and we're receiving that message with this code here. And it's really simple to do that. You can alter these values and numbers and get more into that. That's beyond the scope of this video. But once we do that, we should get the raw byte message from the server. And we're just going to print that on the screen every 2 seconds. And once again, we're going to close that connection. So that's a really high level overview of what's going on between these two code, the code on the client and the code on the server. So I'm just going to run the client code now and show you that it works, just to prove to you guys that this is working. Okay, perfect. So now we're just getting random numbers from the server. And if you go back to the server, we should see those numbers here as well. So that's a high level overview of how to connect two Raspberry Pi Pico Ws on the same network using Thonny and MicroPython. You can definitely extend this to multiple Raspberry Pi Pico Ws to connect to your computer. So I hope you guys enjoyed this video and you were able to kickstart your robotics projects to have sort of more complicated systems where you have sensors across maybe the house or whatever you're doing for different reasons. You know, maybe one sensor is collecting a different type of information and another one is collecting another type of information, and you want a synergy between all of those sensors. So this is a good way to do that, and I really hope you enjoyed this video. If you did, please like, comment, and subscribe to the channel. It would mean a lot. We'll make a lot of useful content for beginners to do things with Raspberry Pi Pico W and other sensors. And if you have any questions, let me know in the comment section down below. And as always, guys, stay tuned and thanks for watching.